Okay, so last class we learned about quadratic functions in general. We learned about what a vertex is. And so today we're actually going to learn how to find the vertex of each function, because sometimes the vertex isn't going to be on the origin or on that y-axis. So in the quadratic function y equals ax squared plus bx plus c, the value of b actually affects the position of the axis of symmetry. Okay, so our axis of symmetry, remember, is that line that if we drew it through our parabola, it would cut it in half, to where if we folded both sides together like a book, they would match up evenly. Okay, so the graph of a quadratic equation, so if we have the graph of y equals ax squared plus bx plus c, where that a doesn't equal 0, that has the line x equals negative b over 2a as its axis of symmetry. Okay, that also means that the x-coordinate of our vertex, so the x-coordinate of the vertex is that negative b over 2a. Okay, so when we substitute 0 into the equation of y equals ax squared plus bx plus c, we get that our y equals whatever that c is. Because if we plug in 0 for x, that means that this ax squared is just going to be 0 and this bx is going to be 0 as well. So that just leaves us with c by itself. So the y-intercept of a quadratic function is just that c. Okay, so we can use the axis of symmetry and the y-intercept to help us graph a quadratic function. Okay. So if we move on to the next page, what we want to do is we want to find the axis of symmetry and then find the coordinates of the vertex. So the first thing we're going to do is we're going to find the axis of symmetry. So on the last page, we said that the axis of symmetry has an equation of x equals negative b over 2a. Okay, so in this equation right here, we have our a just equals 1, our b equals negative 6, and our c equals positive 4. Okay, so what we're going to do is we're going to plug in what we know. So we know that we need a negative b, so we're going to have negative, and our b is negative 6, so we're going to have another negative inside, over 2 times whatever a is, so in this case it's just going to be 1. Okay, so when we have a negative times a negative, that's going to equal a positive, so we have a positive 6 over 2 times 1, which is just 2. If we simplify this, that's going to give us just a 3. Okay, so our axis of symmetry should be x equals 3. Okay, so whenever we have this x equals 3, that means that we have the x-coordinate of our vertex. So to find our y-coordinate of our vertex, we're just going to plug in what we just found for x to our original function up here. So we have y equals 3 squared minus 6 times 3 plus 4. Okay, so that's going to give us y equals 3 squared is going to be 9 minus 6 times 3 is 18 plus 4. Okay, so if we simplify that, that's just going to give us that if we have 9 minus 18, that gives us a negative 9, plus 4 gives us a negative 5. Okay, so our y-coordinate is going to be negative 5. So since we have an x-coordinate and a y-coordinate, our vertex equals 3, -5, okay? Awesome. So the next thing we're going to do is we're just going to plug in 2 other points. It could be any other points that we want to. I like to keep my points around this vertex. So I'm looking at our x-coordinate. So if our x-coordinate is 3, if we go 1 more unit in the positive direction, that's going to give us 4. So if we plug in x equals 4, then y is going to equal 4 squared minus 6 times 4 plus 4, okay? So when we do that, that's going to give us y equals 16 minus 24 plus 4, okay? So when we do that, that's going to give us 16 minus 24 is -8, plus 4 is just going to be -4, okay? So we have a point at 4, -4, okay? And if we picked +5 as our x, so if we have that x equals 5, actually I'm going to grab a different color so we can differentiate. So if we have that x equals 5, okay, then we have y equals, we're going to have 5 squared minus 6 times 5 plus 4. When we do that, that gives us 25 minus 30 plus 4. So that means that y equals 25 minus 30 is -5 plus 4 is -1. So we would have y equals -1. So that would give us a point 5, -1. Okay, so our last step is to just graph the function, okay? So the first step we're going to do is we are going to graph our vertex, okay? So our vertex is at 3, -5. So on our graph, we're going to start at the origin. We're going to go over 3, so 1, 2, 3. And we're going to go down 5. So 1, 2, 3, 4, 5, and graph it. Okay, now we're going to go over to our next point, which we have as 4, -4. So we're going to go over 4 and down 4 and graph that. And our last one is going to be 5, -1. So we're going to go over 5, down 1. Okay, so like we said last time, because this is a symmetric function, that means if we go 1 over from our vertex onto the negative side, so if we go over to 2, we should still be at that -4 because it's going to match up with this 4, -4 over here. The same thing with this 5. If we just go over 1, we're going to be at -1 because it's going to match up with our function. Okay, from here we are going to graph that, and that should be it. Okay, so I want you, if you feel comfortable, to go ahead and start the got it problem. It looks exactly like the one before. So go ahead and pause the video and work on the got it problem. Once you're finished, you're good to come back. Okay, so for this one, we're looking at this function right here. We know that for our axis of symmetry, we have x equals -b over 2a. And we know for this function, we have an a equals -1, a b equals 4, and c equals -2. Okay, so when we plug in our numbers, we've got -4 over 2 times -1. So that gives us a -4 over -2. -4 divided by -2 is just 2. So our axis of symmetry should be x equals 2. Okay, from here we're going to plug this x equals 2 into our function. So we're going to have y equals -2 squared plus 4 times 2 minus 2. So when we do that, we have y equals negative 2 squared is going to be 4 plus 4 times 2, which is 8, minus 2. So our y is going to be negative 4 plus 8, which is a positive 4, minus 2, which is just 2. Okay? So our vertex should be 2, 2. Okay? So if you want to go ahead and plot that on there, I'm going to go ahead and plot it. Our vertex should be right there. Okay, now we're going to find 2 other points. So I'm going to go in the positive direction from my vertex on the x-axis. So that's just going to give me 3. So we're going to have x equals 3. When x equals 3, y is going to equal negative 3 squared plus 4 times 3 minus 2. So that gives us y equals negative 9 plus 12 minus 2, which means y is going to equal negative 9 plus 12 is 3, minus 2 is just 1. So if we have x equals 3, we have y equals 1. So our point should be 3, 1. Okay. And another one, if we go over to 4, so if we have x, I'm going to use a different color. If we have x equals 4, then we have y equals negative 4 squared plus 4 times 4 minus 2, which means y equals negative 16 plus 16 minus 2, which leaves us with y equals negative 2. Okay, so that next point is going to be 4, negative 2. Okay, so if we go ahead and graph this, we should have our vertex at 2, 2. Then our next point we're going to graph is 3, 1. So we're going to go over 3 on the x-axis and up 1 on the y-axis and graph that point. Because we have that point here, if we go over to just 1, since it's symmetric, we have that other point at 1, 1. Okay. Then if we go over all the way to 4, it tells us to go down to 2, down to negative 2. Okay. So if we do that same thing, we're going to stay at 0 and we're just going to go down 2. And that gives us our nice parabola to graph. Okay. So I think that should be all of our notes for today. If you have any questions, please let me know. Otherwise, go ahead and start working on the worksheet.